Hi folks, we're going to take a look at page 140, number 13. So first of all, they ask us to find the family of cubics with these zeros here. So since they don't specify the orders, we assume that they're order 1. And of course, if there's 3 of them with a cubic, that's at most what they could be. And then they want us to find a particular member of this family, one that passes through 220. Okay, so let's start with A. And we know that if a polynomial has an x-intercept of order 1, then we know that the function has a factor of x minus that number. Okay, so in this case here, x minus 0, that's just x. So here's one of my factors. Then another factor is going to be x minus this first one given here, 2 plus root 5. Now remember, I'm subtracting this whole number, so make sure that you're writing down, you're using brackets here. So 2 plus root 5. And then x minus that last one, which is going to be 2 minus root 5. Okay, and this is just one member of the family. In order to get all possible members, we can change this constant multiple in front. It could be any number, well, except 0. So we know that k can't be equal to 0, but any other value for k is going to give us a polynomial that has these characteristics. Okay, so there's our family. Let's go to B, and here they want us to find a particular member of the family. By the way, just to let you know that I think the textbook gives this multiplied out. I'm not expecting to see it multiplied out. Okay, especially if this takes too much time. Algebra I don't need you to do. So now we want to find a particular member of this family, the one that passes through 220. So now we have that extra piece of information we need to find the particular k value. So we just input for y 20, and then we're going to input for x 2. And then we'll have enough information to solve for k. And actually this looks like it's going to be, sorry, that's plus. This is going to be a pretty nice one here. Okay, because we're going to see that these 2's happen to cancel out. So let me start by dividing this 2 to the other side, just to get it out of the way. So 20 divided by 2 is 10. So here, what are we left with? We're left with 2 minus 2 is 0. Okay, but don't forget we're subtracting this root 5, so we're left with a negative root 5. That's all we have left in the left bracket. And here again, 2 minus 2 is going to be 0, but then minus negative root 5, it's going to be plus root 5. Okay, so in the end, we've got negative root 5 times positive. So negative times positive, we're going to have a negative there. Okay, and root 5 times root 5 is just 5. So we just have to divide. Left and right by negative 5. So we're left with k equals negative 2. Okay, so our particular member of this family is going to be equal to negative 2 times x minus 2 plus root 5 times x minus 2 minus root 5. Okay, and that's it for this one. Just a quick recap again. We know that when we're given an x-intercept of a polynomial, that means that x minus that number is going to be a factor. Okay, and just knowing the zeros doesn't give us one specific equation, but it gives us a family of polynomials. In order to find the specific member of that family, you need another piece of information, which is usually another point on the polynomial. Okay, that's it for this one.